for developers watch back later, they won't have to hear my intros. They can just get straight to the code.
Yeah, now it's recording.
Okay. All right, let's see if this lets me share my entire screen. Okay. I might have to exit and rejoin. We'll see. Give me 1 second. Let's see. All right, you guys are seeing my desktop?
Yes, yes.
Incredible. Okay. I have all these annoying Zoom pop-ups on my end. Okay. So again, for anyone who just joined or for anyone who's watching back this stream, what we're going to do now is we're going to do a basic overview of Secret Path, which is the bridging solution we created that connects the EVM with Secret Network. Then we're going to look at some demos on Secret Network that utilize Secret Path and have connected EVM chains with Secret to see kind of what's possible with the Secret Network tech stack cross-chain. Then we're actually going to dive into the code and look at this behind the scenes so that you understand how to set this up on your end and have a repository that you can kind of get up and running with right out of the box. And then lastly, we'll just open up the floor to questions. So to start, this is Secret Network's docs. If you just Google Secret Network documentation, this is where all of this lives. This is like our source of truth for developers. And specifically what we're looking at today is the EVM developer toolkit. So in this, we have two cross-chain messaging solutions, which is Axelar GMP and Secret Path. So you can use either of these to pass messages between Secret and EVM chains. What we're looking at today is Secret Path because it's cheaper, it's faster, and I think it's kind of just built better for this use case. Axelar, though, just for anyone who's has never used Axelar before, Axelar is good for cross-chain token swaps. That's the one instance where I would recommend using Axelar over Secret Path for cross-chain token swaps. But so what Secret Path is, it's a privacy-preserving message passing solution between EVM and Secret Network. And basically the way this works at a high level, there's actually an architecture picture here. This just makes things more confusing though. I think it's a lot of things going on. For each chain that we're connected with on the EVM, there's a public smart contract and a private smart contract on Secret Network. And these chains, or these contracts, communicate with each other with elliptic curve cryptography. So maybe you've heard of ECDH before, elliptic curve Diffie-Hellman. It's a cryptography solution where we're able to generate a shared secret between two different parties. And we do this with Secret Network in this private gateway contract for each chain. We have a public and a private key that interfaces with the public and a private key of the public smart contract for each chain. And so that's how that works at a high level. You don't need to know too much about that right now for us to actually dive into the code. But if you go to the supported networks in our docs, you can see all of the contracts on mainnet. These are all the EVM networks, and then all of the EVM contracts on testnet. And basically all you need to know is that if you want to, be able to have applications on any of these EVM chains that communicate with your smart contract on Secret Network, you just have to pass it through the gateway address of that chain. And what we're going to look at right now is various demos where it showcases how to set this all up out of the box so that you don't even have to worry about that. It's all been abstracted away for you underneath the hood in our React.js application. So let's do that now. We're going to just look at some demos very quickly. Actually, we can just go into here. This is my personal GitHub, Riders Blockchain. Thank you. I also think it's a very cool name. Okay, so let's start with this. We'll look at 3 demos today before we actually dive into the code. This is just a voting application. And what you're actually going to be learning today is how to set up cross-chain randomness between Secret Network and EVM. So to receive a verifiable random number, which we from an EVM smart contract. And we're also going to learn how to connect Wallet Connect to your application in React.js. So that's what this is right here. This is a wallet connect Web3 modal. If I connect wallet, I click this button. What then happens is we can choose between every single network we're connected to on Secret that I just showed you, and those gateway contracts through mainnet and testnet. These are all already programmed in here so that you can have one contract on Secret Network, and all of these EVM chains are able to access that one smart contract. So like, this is a voting demo where we can create a yes or no voting proposal, and then people can vote on it. And then we set an amount of time for it to expire. And so I'm doing this with a testnet on EVM called Metis testnet. Maybe you've heard of it, maybe you haven't. I can create this proposal. And then as soon as this is picked up by the secret path relayer, we're actually going to be able to view the proposal and see it on chain. And then like we can actually see this transaction hash right here. This is logged to the terminal. So if I were to go to like the Metis testnet explorer and go to that transaction hash, we'll see that transaction here happening on Metis testnet. And then if I go back into the secret voting application, I can now view the proposal. And oops, vote on this proposal. Obviously, Cosmos Brazil rules. We're going to vote yes. So that's one example of something you can do with Secret Network, is like, because the issue with EVM, a lot of these chains are public chains. So everything you publish, your things are revealed on chain. This is a way in which you can have private voting on EVM using Secret Network. So you're able to vote with your EVM public chain, whether it's Metis or Sepolia or Polygon, whatever it may be, but your payload is actually encrypted and stored in a Secret Network contract, and it's passed from your network using this gateway address to Secret. That's the voting example. That exists in our doc, so you can see exactly how to do this. You can look at all the code and start with that as a starting place for you if you'd like to make a voting application. We also have, this is kind of a fun one. This is a randomness demo that I made called Secret Path Balls. For funsies, let's just switch to a different network like Sepolia, just to show how we're doing this on any cross-chain compatible EVM chain that we're compatible with. So now I'm switching to Sepolia. What this does is it receives a random number from Secret Network. We request the random number on Sepolia, and it is received from Secret Network. And it's programmed so we receive a random number between 1 and 200 on chain. And then whatever the number is that we receive, there's going to be a random number of balls that are that number. So, or say, give me secret balls. Sign this transaction. We receive a random number of secret balls. That's that. And I'm just going to do one more demo, just to kind of get in your head what's possible with secret contracts cross-chain before we actually dive into the code. I just made this week. I don't have docs for this yet, but docs will be live next week. So this is cross-chain NFTs. So we have a Sepolia contract here, and we can generate NFTs on Sepolia or any chain that we set this up with on EVM, and then have private metadata that is only revealable on Secret. And it's also connected to OpenAI. So we're actually going to generate our NFT image with AI technology. So let's just do that really quick, just so you can see kind of what's possible. Go here. So yeah, those NFTs we just viewed. On OpenSea, you're able to see the owner and the token ID and the name and the description, but you can't see the private metadata. You have to have the password, which is stored on Secret. And the private metadata is stored on Secret. So let's actually just make one and just see how this works really quick. So let's call this Cosmos Brazil. The NFT description here is actually the prompt that is being passed to OpenAI to generate our NFT image. So I can say Cosmos Brazil, cartoon, Luca. I have no idea what this is going to generate for us. And we'll make our confidential message that's saved on Secret Network. I love Brazil. And we'll make our NFT password Brazil. Okay, so we're going to create this NFT and it's going to generate the image using this as the description that passes to OpenAI. I have no idea what this will make. Okay. So confirm. This is our our Luca NFT for Cosmos Brazil. Pretty incredible, if I could say so. And so now we should be able to see this NFT on OpenSea. Let's see. See the. Let's make sure it went through already. Okay, it says confirm, so we should see it. There it is. Awesome. And now if we go back to our demo, right? So if we click on this on OpenSea, we can see the name and we can see the description, Cosmos Brazil cartoon, Luca, but the private metadata doesn't exist. It's only stored in the secret contract. So we go back to home, view NFTs, see if this was successful. Here we go. And if I enter a password that's not Brazil, this will fail. But then if I have the private password, I can reveal this private NFT metadata that's stored on secret network. See, I love Brazil. Can you guys still hear me? I just want to make sure I'm still live with you all.
Yes, 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 yes.
Okay, amazing. All right, so those are the demos. Does anyone have any questions before we actually dive into the code and start learning how to do this ourselves?
I'll just add some personal comments here around everything you showed. When we talk about secret and when we talk about privacy with smart contracts, basically this is the future of any application which is using blockchain in the real world, right? This example of a secret NFT, for example, like it was very cool. Actually, the demo, I like it. Send me this NFT, I'll put it as my profile. But but like these secret NFTs, like we can do so many things with like we encrypted data inside our NFT. Like we can say this for real estate, we can say this for commodities, or we can say this for a fun engagement. For example, imagine the person you are a biggest fan, an athlete or a singer or anything, they are selling a NFT online, and only the owner of this NFT has an encrypted message from this author saying something special to him. So imagine we are doing this on OpenSea. Anyone can see this NFT. It's not special, you know? And that's why sometimes people used to ask, like, okay, this is an Neymar NFT. Okay, it's a monkey, and I can take the same picture and use it. What's special about it? So when we use secret NFTs and encrypted data inside an NFT, we can really create something special which only the owner can see, and he has the option to share or not with others. So a secret is all about this, like the name secret is like everyone has secrets and everyone decides to share this secret with his wife, with his personal biggest friends. You don't share your secrets to anyone. So that's a little about the idea as well here. Go ahead.
Yes. Okay. All right, so I just linked everybody to the repo we're going to be working with in class today, and I'm just going to clone it down right now so you can do this live together. Okay. So we're going to start by deploying our own randomness contract. And it's going to be the exact same randomness contract we just used for the demo with secret balls. So I just want you to see, see what that looks like behind the scenes. And I'm going to explain this as if you're an EVM dev who's never seen a Cosmos WASM smart contract before. Just kind of give a high-level overview, and then we'll actually look at the contract itself. So if you've never seen a Cosmos WASM smart contract before, basically cargo.toml is all of our imports. So this is like where we actually import the Cosmos WASM SDK so that we can write our smart contract. And if you're working with secret network smart contracts, there's certain dependencies you need that are specific to secret. And you can see all those here in our cargo.toml. If you're a JS dev, this is just like the package.json basically of your smart contract file. So yeah, you can see we have some specific secret imports here like Cosmos SDK storage, Cosmos STD, and specifically the secret packages. Then our actual smart contract code exists with these 4 files: state, message, lib, contract. Lib is 3 lines. All it does is makes it so that these other 3 files can communicate together. This is our library. That's all that is. It's just the name of those other files. State is the actual state we're saving for our smart contract. So what we have here is a gateway address, a gateway hash, and a gateway key. This is the information we set up to make this accessible to secret path. So this is kind of like boilerplate code that we save to our state. You don't really need to know about that, but we're actually going to upload a smart contract together today onto secret testnet. And so you'll see how I actually use these variables to make it so that this contract is compatible with secret path. So we can do this cross-chain bridging. And this is what we're actually saving to the smart contract. This is literally the only thing. We have a stored random key map, which is a bool, and this struct random. So every time a user executes the smart contract, what we're going to do is we're going to save a random U8 and the wallet address of the person who called the function. And that's what's going to be stored in this key map. And then it's just going to be overwritten each time somebody calls it again. And it's just going to be set to true every time someone requests a new random number. This is just like a super basic implementation just to kind of get hopefully the basics across to you. So that's the state. All we're saving is this one random number, right? It's a U8 and the user's address. Message RS. This is what the contract actually does. So whenever I'm like looking at some new code that's like a Cosmos smart contract, the first thing I do is I open this message.rs file, because this is like how I understand like what are the functions the contract is actually executing. And what you'll see is there's 3 entry points is what they're called in Cosmos contracts. There's the instantiation message, which that should be familiar if you're coming from Ethereum. So we have an instantiate message, which is just initting the contract, putting it on chain. There's an execute message, which is this is like what the contract is actually doing. This is the function that changes the contract state. So in this case, it requests a new random number and then saves it to the contract state. And lastly, we have a query message. So we're able to actually like have a query that retrieves the random number from the state of the smart contract. Does anyone have any questions about that before we actually look at the contract logic? All right. So the contract file is where the logic of the contract actually all comes together. This is a pretty simple smart contract. We only have like 140 lines of code. And this is where we have our instantiate message, our execute message, and our query message. And you'll see up here, we have these crates that we import. So these are what we import in our cargo.toml file. And then we just need to actually bring them into our smart contract files to actually work with those imports. So we're importing this. We have these imports in cargo.toml, and then we actually use them in our smart contract. And in our instantiate message, we instantiate it with the gateway address, the gateway hash, and the gateway key. So this is like the ECDH, the elliptic curve diffie-Hellman stuff I was talking about, that allows us to create this shared secret between other chains on EVM with our secret contract. These variables all exist in secret docs. So like if you go back here, we can see our right here, like we have our gateway contract address, our gateway contract code hash, and the gateway encryption key. So when we actually go to instantiate this contract, we're going to have to pass that information to the contract state. We will do that momentarily, so you'll see how easy it is. I already have a Node.js file written so that it all does this automatically for us. And then our execute message, it's just this one thing, try handle, which receives this handle of request random, which calls this function try random. So if you're new to Cosmos, don't worry about like the exact nuances of how to structure this, but just know that this is like very much boilerplate code. It's repetitive. There's certain patterns to this, and the more smart contracts you look at on Cosmos, this will just make sense over time. You'll just understand like the formatting. But all you need to know is there's this request random handle, and this is designed in a way in which from EVM, we're able to send that handle to this smart contract. It's able to receive it as an input, right? Right here, it receives this string as an input. And then it knows based on that handle name, based on this handle name request random, to call this function that we wrote, try random. And in this function, try random, is where we actually say that we want to receive verifiable randomness from the current block of secret network and make that a number, a U8 between 1 and 200. And then just save that back to our contract state with this random struct that we created in our state file. So I format it to be saved back to this random struct with the U8 as well as the wallet address that's actually calling this. And then I insert it into that key map that we looked at in the state file stored random. And then we have some boilerplate code here for CosmWasm where we format all this information and we return an OK response. And then we just have a super basic query message on secret that allows us to actually query what our new random number is. Does anyone have any questions about that before I actually upload and instantiate this smart contract to the blockchain? All right. And Luca, you can still hear me okay?
Yes, sorry.
Great. So, I'm just CDing into this node folder. I'm going to install the package dependencies. So just npm install npmi. All right, I already have like my testnet mnemonic added here. So it just has my testnet fund, so I can actually upload this to the secret blockchain. And then if we look at our upload script, we'll see again, remember those 3 variables I said we needed to define in state, the gateway hash, the gateway public key, and the gateway address. I already have all 3 of those included here in this script so that when we call upload and instantiate, it's going to pass those 3 variables, those parameters for our init message. So I can just run the code. I can just run node upload, and it will upload this code to the blockchain for us. But first, I need to compile the smart contract, which actually, this is my compilation script. I need to make sure I'm in the correct folder. So I'm in the contract folder. I'm going to run make build mainnet, and it's going to compile the smart contract for us so that we can then upload it to the blockchain. And just give it a second. I'm drinking a homemade mango smoothie today, folks. I highly recommend making your own smoothies. You save a lot of money. It feels good for your health. All right. Our contract has been compiled, and we now see it here. We have this contract.wasm.gz file. And we'll see in my node script here, if I look at node upload, that this is written in a way where it actually takes that WASM file and reads it from here, from contract.wasm.gz. See? And this is what we're actually uploading and instantiating on the blockchain. That's the WASM, the compiled smart contract. So let us do that. I'm going to run node upload. All right, our code ID is returned along with the contract hash and a contract address, okay? And now what we're gonna do is set up our front end to actually be able to interface with this code. So our front end is a React application that's pretty basic. It has two functions only, one that queries the secret contract and one that executes the secret contract. So I'm going to take this contract address and paste it in here along with the code hash. And same thing. We're going to look at this in a second in more detail, but we want to make sure that we point the request random function to our new smart contract. Okay, so let's actually open our front end now. So I'm going to cd into front end, and I'm going to install the dependencies once again. And we will run it in localhost. So npm run start to actually run the application. And the goal of this is for you guys to be able to clone down this repo and have this all working immediately out of the box, so you don't have to do anything. See, okay. So this is just like a stripped down demo, what we just looked at with like the secret balls where we received random balls between 1 and 200. Now we just receive a random number between 1 and 200 by clicking this button. So I request randomness, sign this message, confirm the transaction. It says undefined. Oh, it's probably because it just requested it. It's not there yet. Let's see. Because there's currently no random numbers stored in the smart contract yet because we just instantiated it. But now I think if I request randomness, there should be a number if we did this right. Maybe. And if not, maybe I'm using a different smart contract and I've forgotten. Make sure I'm using the right contract address. IJ. Ah, look at that. I pasted the code, the contract hash wrong. BFA is how it ends. Okay, maybe that will fix it. Let's try that again. So we first have to request this. That makes sense that it's undefined because it would be the first call that was successful so far. And once this goes through with the correct address and code hash, I think it should be successful. Let's give it a second. There we go. Error handling on the spot, folks. Okay. So let's actually look at how, like the whole goal of this for me is for you to see this, have a light bulb moment, understand how you can just clone down this repo and get building your own secret path dApps so that you are connected cross-chain from any of these EVM chains with secret network. And so the point of this is we already walked through a secret contract. I'm going to show you how to actually call that contract with secret path and also how to set up wallet connect so that you're connected to all these chains. Because if I go in here now, we can choose between any of these chains and be able to execute this secret smart contract. And give me 1 second. I'm just gonna blow my nose. I'll be right I will be back in 10 seconds. All right. Let us proceed. So if we look at this code, we go into our app.js function. What we will see is like roughly 60 lines of code. And there's three things that's happening here. We only have two buttons, right? We have this wallet connect button and we have our request randomness button. And there's three functions though. There's fetch chain ID, which is a use effect, so that every time we switch chains between a different EVM network, that new chain ID is logged to the React state. And the reason this is important is because the way I designed this boilerplate, like out of the box code for you guys, is that secret path automatically is aware every time the chain ID switches, and then it automatically knows that it needs to then call that EVM gateway address. Because remember how I showed you how each of these different chains has a different gateway address associated with it? Based on which chain ID is currently logged into MetaMask, we can point React to the correct gateway address so that then whichever chain someone's logged into in their wallet, they're automatically executing that gateway address for EVM so that it's talking to the correct contract on Secret Network. So that's what this use effect allows us to do right here. And you'll see that like in the terminal or in the console, if I open it up, it'll say that what the current chain ID is. It's logging it here as well as saving it to the React state. Okay, we have like 14 minutes left. I'm gonna try to speed run this. And then secondarily, we have a query function and we actually have our request random function. So the query function is just a really basic query where it's just querying the secret smart contract. If you are a Cosmos developer, this should look familiar. We just set up our secret CLI, our secret network client here with the RPC and the chain ID. And then we just pass the name of the query that we defined in our secret contract, which is retrieve random. And then that's what's actually being returned to us, is that random number along with the wallet address. Here's the one scary part. Actually, before we do that, all you need to know to set up Wallet Connect for yourself, if you want to do this like after this call and have it set up working for you in 5 minutes, is the only thing that you need different from what I have here in this code base is your own Wallet Connect project ID. So if you go to Wallet Connect and developers, docs, get started. Okay. If you go to their documentation, it teaches you how to create your own project ID. And actually, even better yet, if you guys want to have like documentation that walks you exactly through this with like a little more handholding after this call, I just wrote docs on this in our documentation. So if you go to basics, secret path plus wallet connect integration. So check this out. But all you need to do is create a project ID. So I open Wallet Connect. You can sign into Wallet Connect with actually your wallet, your MetaMask wallet. And then over here on the sidebar, it says projects, and then you're able to just create a new project. And then when you do that, it will create a custom project ID for you. So I already generated my project ID. And let's actually go to the Wallet Connect component. So you'll see again on our app.js homepage, we only have these two buttons, right? We have the one button that handles the submit, and then we have the Wallet Connect modal. So if I open this component, to set up Wallet Connect, you need like 5 things, and almost all of it is just boilerplate Wallet Connect code. One is your project ID. The other is this object that's your metadata, which is just like the name and description of your app. So, you know. One, yes.
Take a look on a question in this chat, please.
Okay. You're asking like the only like wallet provider.
Yeah.
This is the only one that we've done like all the UI work for. So you could integrate with others. This is just me showing how to actually to do this. Does SDK work with TypeScript? Does it have hooks for React? Yeah. So if you actually go to the Secret Labs code base, a lot of what they do is in TypeScript. So these are the core developers behind Secret Network. Like you can go into, actually, let's do this. Let's go to Secret.js templates. I think these are all written in TypeScript. Let's see. Is this TypeScript? I'm not sure. But yes, it's TypeScript compatible for whoever asked that question. And you can find examples specifically with TypeScript in Secret Labs' repos and actually in Secret Network's docs. Let me link you really quick. In our getting started section, there's a full stack dApp integration. And this is a full stack dApp created with TypeScript and Secret.js. So you can see this as an example. And I think in this example too, we set it up so that it like uses use context to pass your secret wallet address through like every page of your TypeScript application. Okay. So back to Wallet Connect. And like you don't, yeah, like I said, you don't need to do this with Wallet Connect. This is just showing if you want to make this like really seamless UI experience. But like in the example of the NFT example that I was showing earlier on, that's just happening with like hard hat behind the scenes with Sepolia testnet. Okay. What were we doing? Oh yeah, Wallet Connect. So to set this up, you pass like 5 parameters, and it's like mostly boilerplate. The metadata object, the project ID, others config, which you don't have to change this at all. And then there's chain images, which is just the chain ID and then the logo of the chain. So this is just, if you want to make it look pretty, you can add logos for each chain that you have integrated. And then there's the actual configurations for the chains themselves. This is it. And this is already all done for you in this code. If you go into this config file, this should look familiar to you. It's just like the MetaMask RPC endpoint configs. And this just makes it so that like the wallet is configured properly with Secret Path. So for every chain that we want to include, we just set up the configuration in here with like the chain ID, name, currency, Explorer URL, and RPC URL. And then we pass that information to Wallet Connect in this Web3 modal along with the project ID. And from there, voila, we have this button all ready to go. And that's how we're able to have this here, have this beautiful UI that's connected to 20 plus EVM chains and working with Secret Network. Now, here's the juicy part. This is like if you're a Cosmos dev or an EVM dev who wants to make your own customizable smart contracts. So the way to think about Secret Path is like what you can do is you can like design any contract on Secret Network and then basically use an EVM network as like the controller of that secret contract. So this way you're just bringing like encrypted payloads or randomness or whatever else to EVM users without them actually having to understand the complexities of like the underlying cross contract integration. And the way you do this is, remember how before we were looking at the message handle, we were saying that the function we wanted to call in the secret contract was like receive random. I'm going to show you right now what that actually looks like in the Secret Path code that's calling that. And then also just explain kind of a little bit how you would change that to work for whatever contract you have deployed on Secret. So the only other function we're going to look at today is this request randomness. This is like pretty much all boilerplate code except for like 3 things. And this is basically just designed so that like this elliptic curve Diffie-Hellman protocol is happening underneath the hood where we're creating this shared secret. You don't have to change any of this except for, oh yes.
Sorry for interrupting. Let me make a dumb question. Yeah. Always when you put the RPC configuration, for example, can you go to the wallet component, direct component, wallet connect? Yep. Yeah. Up. There's there's a configuration that you put the chain ID together. Yeah, you have the RPC address and the chain ID. This chain ID is a handle name just for make the unique value and the depth, or it's a specific number.
This is specific number. This is the actual chain ID of the network.
Okay.
So in your RPC config, like for example, if we go into MetaMask and we say settings, networks, add a network manually, actually cancel. We'll see that this is like the chain ID of Sepolia, right? This is the chain ID of Polygon. These are the same always. And passing this info in, we're just saying that for that particular chain ID, use this logo for our UI.
Okay, got it. Yeah.
Yeah.
I have another question. Is almost off topic. Yeah. What the necessary chain ID? Because I guess that RPC address is the enough to get the correct network. Yeah. What the which the case that's necessary, I have different chain ID to the same RPC address.
I'm not sure why it's set up. This is just what you have to do if you want to pass chain image logos to Wallet Connect. But yeah, I think it's kind of arbitrary. Probably also could have been done with the RPC. All right, for sake of time, I'm just going to discuss this very quickly and then see if we have any questions. So all that we have to change in here is the contract address and code hash, and then the actual name of the handle. Because we designed our secret contract in a way where we don't actually need to pass any information to the contract in order for it to function correctly, we can just, all we have to do is actually call the contract, which happens with this request random handle. So that's it. Literally, we had to change 3 lines of code to make this work with secret path, point it to our correct address, and then change the handle. But if, for example, like in the NFT example, we have to pass the secret password and the private metadata to the secret contract, right? So if we were to look at that contract, just to kind of think about another use case. This is all like, looks like very similar. The difference here is instead we're calling a different handle. We're calling the handle, so instead of like receive random, we're calling execute store confidential metadata. And that's just going to be the name of the handle in our secret contract, right? So if I go back to my secret contract here, contract, and I look at the handle messages, we still have the same try handle function, but it receives 2 different messages. Our handles, or actually just receives the one, huh? So it receives this execute store confidential metadata, and then when it receives that, it then calls that function. And this function takes user input. This is how this is different, because we're actually passing messages from the EVM. We're passing user information. So we need to receive the owner, the wallet address, the token URI and the token ID, the private metadata, and the password. And all of that information, if you look back at the secret path logic, is just being sent here. Right here, we just create a JSON.stringify object called data where we pass all that information. And so this information is being passed along with the handle that we call to the secret contract. And then that function actually takes this information, this data, and uses it in the secret contract in a way in a logic that we define. But all that to say, the way, if you want to get really like technical with secret path and have your own specific use cases, you basically just create a secret contract to your liking that does everything you want to do, and then just write this logic to be able to pass that information along to the secret contract from EVM. All the rest of this is just boilerplate data. So like in the way that I said, we have the use effect hook where it saves the chain ID to state so we know which secret path gateway contract to call. This is just like 50 lines of code that's just an if statement, and then based on which chain ID is currently logged in, that's how we know which EVM gateway contract to call. And then the rest of this is just boilerplate code where we're just correctly setting up the payload information, and none of this you have to actually change. And with this though, with this framework, this infrastructure, you're able to have cross-chain smart contract calls between EVM and secret network between 20 plus connected chains. So that's the demo for today. I want to open it up to questions now, and hopefully this kind of opens your minds to what's possible with secret contracts and being able to build full stack cross-chain applications.
Nice. So I want to highlight the secret hackathon for a while, but let's just leave some questions. And I also want to mention some personal opinions again. Any question? To leave. Thank you.
Luca, I would like to thank Shan about this lecture for us, and it's interesting because you open a lot of interesting things to make. For example, I saw the example of the NFT with the password. For us, it's very interesting because we can use in some real world applications, not real world assets, but real world applications here in our ecosystem. We are working now with some Web2 startups, and it's interesting to see possibilities with certification. And for example, you can send to a customer an important certificate or information the customer open only with a password sent to me. For example, I have sensitive documents about certain situation or certain product, and my customer will open only with open the password we can send to us. It's interesting because this future is very important to make some certifications applications here in Brazil. I like this future, and for me it's very interesting because security opens up into us a lot of important things and a lot of important opportunities here in Brazil. We'll take a look better in your samples and libs in the GitHub, because I saw a lot of interesting things we can see here in this lecture. But thanks again for your time and your experience.
Amazing. Thank you, Antonio.
Any question, guys?
Yeah, I have another question. For example, assuming on cases that you have a bank, yeah, and I wanna make a bank on chain, full on chain, yeah, and I have a transactions between two persons, yeah, and only this person can see all metadata, for example, transaction value, transactions created at, timestamp, yeah. And is it possible because
Você me entrega, Fabiana?
Tony,
because
muta aí, por favor.
Mercado Livre, né?
Well, can you mute Antonio, Luca?
Done,
There we go.
done. Yeah.
because in your example, I saw the encrypted, yeah, decrypted the metadata message just once time, yeah. And I wanna always put password and get the decrypted value. It's possible,
Mhm. Yes.
yeah. Okay.
Yeah. So a way that like this works with like secret tokens, for example, on Secret Network is they're created with viewing keys. So you can have a viewing key associated with a token where then only certain people who have the viewing key can actually view how much like you have of that token, for example. And you can program whatever you want with a viewing key of like what access people actually have with querying token information.
Got it. Because in this case, it's necessary two person can see the transaction information. Yeah, did you get me?
I think so, yeah.
Yeah. Okay, got it. Yeah, perfect. Is there an example about this case and source code to that I can see? I can study.
Yes. Let me see. I think a good place to go for this is, where would this be? Check out these Secret.js templates,
Okay.
specifically snip20 token.
Okay.
This will show how to like create your own token with the viewing key and your own contract address with this token.
Okay, perfect. Many thanks.
Yes, before we do more questions, in case anyone has to drop, I just want to announce that we have Hack Secret 3 happening right now. I just linked that in the chat. It's the Dora Hacks link. So we currently have 8,000 USD in prizes for hackers, and this is going on to like June 20th. So if you're a Cosmos dev or like you're interested in submitting a project, or you're an EVM dev, there's a cross-chain track that's 5,000 USD dollars. USD, that's an oxymoron. For cross-chain applications.
Sure.
So if you have an EVM compatible app with Secret Network, you're eligible for this prize.
Can you share your screenshot? Do you still have some time, some minutes, or you need to leave?
Oh, just share the Dora Hacks.
Yes, it's go ahead.
So, okay, yeah, so this is the page. If you just search Hack Secret 3, we have 26 days left. It just launched this week. And all the details are here in this details tab. And we also have ongoing workshops for the next few weeks. So if you want to see more live workshops, but the main thing is there's 8,000 USD, 3,000 is reserved for apps built just on Secret, and 5,000 for apps that are cross-chain. And you can also submit to both categories. Yeah, I definitely highly recommend submitting to this. Even if it's just like for a learning experience, like submitting to hackathons is the best possible way to actually like learn things, unless you're like working in Web3 full time. This will just like take your knowledge to the next level because you're going to figure stuff out that you didn't even know. I don't know, like the more you get into the weeds, the more you realize how like complex this stuff can actually be. But having a deadline in sight helps you actually get something done, and it will take your learning to the next level.
Nice. Does anyone have any question more? I'm gonna just make some comments here now. And as I said, this is not my personal opinion, but guys, like Web3 and crypto is everything so new, and we see so crazy things happening every single day. And of course, we're dealing with software and development on a chain, but we are also dealing with tokens, which makes a whole economy inside each chain, right? So we have many new chains arriving, which inside the tokenomics of the projects, like they have a lot of money to spend. But the same way they have a lot of money to spend, they have a lot of tokens inside like the team. Like the team sometimes have 50% of the chain in tokens. So this is just an example, but some things we need to take care and watch. And Secret Network, for example, I'm here for almost 3 years now, and I saw like all of these new chains who are now arriving and spending a lot of money in hackathons, hacker houses, or wherever. I saw Secret doing this some time ago and learning from this process. For example, right now, Secret, almost all tokens are circulating, like there's no unlocks anymore, which is very interesting. And this is something as a developer, we sometimes we don't look at, we don't understand. We just want to code, and I'm sharing a no developer experience here, which is important as well. So I see Secret really ready for just to grow from here. Like all tokens are circulating, all code is there, all documents are more than ready now and open source to anyone to build. And privacy is the next thing for any application we want to do to really blockchain become uh, uh, to have real impact in the world, right? Uh, Many chains, they just like many founders which just launched a chain, they just want to get millionaire. That's the truth. They don't care about if the chain is really sustainable or if the chain will perpetuate for 10, 20 years. They just want to be a founder and launch a token, and in some years they will become a millionaire, and that's it. And even Secret had this time, like there were some new millionaires in Secret, but right now it's all here. The token is here, the code is here. There's no best chain to integrate privacy as Secret. So I think like Secret has a future for the next 10, 20 years, in my opinion. So this is great. I think it's a great place to learn. And we are having hackathon, we have Sean, we have many developers who will give everything they have to help you. So yeah, I'm also here to speak Portuguese with anyone who is interested. That's my whole feedback, and as I said, my personal opinion. So if anyone has any more question, please.
Luca, I would like to make a final statement with the people here and to Shaw too. Shaw Luca is a guy which present to us here in Brazil, the Cosmos. Well, my name is Antonio or Tony. People call me Tony. It's better. It's easy. I'm CEO now, and Priscilla, Baeta Priscilla is my COO of a Web3 hub here in Brazil, called Node. And now we are working with some protocols, and Luca told me about a lot of secrets and the importance of the secrets in the Web3 environment, the Web3 ecosystem. Okay, and I think it's an important thing which Luca talked in this statement some moments ago. And there are some founders which launch only tokens for make money fast and forgot the essence of the things and the importance of the business. Okay, now we are here in Brazil trying to create a business ecosystem in Web3 which bounds Web2 companies, Web2 corps, Web2 startups using Web3 technology. And Cosmos to us today is one of our main protocols of blockchain. We are working today with Cosmos and Polkadot here in Brazil with our ecosystem hub in Lotus. Or obviously EVM2, because in Brazil there is a lot adoption of EVM for some important projects. For example, Drex, a governmental project of Central Bank of Brazil. We try to create a digital real using blockchain, but I think now it's far from the original point and have some issues and some problems which can see in the last month, and probably Drex here in Brazil only in 2025 or 26. But now we are working to try to create these business ecosystems, and I'd like to invite you, who will come from here in Brazil, someday here in Brazil, to make a personal lecture for the Web2 startups or Web3 startups about the potential of the secret with some business in some important projects here, using security and using Cosmos infrastructure. Okay, for us, this lecture was very important because you open some important and we clear some paths to think new projects using secret. And when I talk to Luca here in WhatsApp, man, I love a lot this thing of password NFT with the password open, a lot of important things for some projects here. And I think I think soon we can create a project here in Brazil using secret. I believe on that because the project is very strong, very solid, very secure in my opinion. And I saw you can reach some new boundaries in some projects using security and use some important certification features here in our Web2 ecosystem. I'm a Web3 guy, Priscilla is a Web3 woman, but now we are in 2.5 web because the main idea today, 2.5 web, because the main idea today is bring the Web2 to Web3 and using the technology of Web3 in a real way, not only, okay, when I saw I have an internal joke here, only using magic coins, like, for example. That's the main idea. Thanks a lot for your time, man.
Thank you. All right. Thank you, everybody, so much. And Luca, thank you so much for organizing this. I really appreciate you having me on, sharing this afternoon with everybody who is here today.